All right, let's take a look at more complex force problems. Now, if you take a look at the document that's going to be uploaded along with this video in Google Classroom, you'll see in question 3 a problem that looks like this, where you've got a ball suspended by two strings that will be exerting two forces, tension 1 and tension 2. One of them is 37 degrees below um, the roof level, and one is 53 degrees below the roof level. Now, the first thing they want us to determine is the weight of the ball. Well, the weight of the ball is easy enough, right? Fg equals mg. Right, so Fg equals 0.5 kilograms, the given mass of the ball, times g, your acceleration due to gravity, so Fg equals 4.9 newtons. Second thing they want us to do is a free body diagram. So you got your ball, you got tension 2, you got tension 1, and you got mg. Now the third thing, and the most difficult one, is they want us to find those two unknown tension forces. Now, in order to do this, let's go ahead and draw this picture much bigger. So this is T2. This is T1. And this is, oops, ignore that arrow, should keep going down. This is mg. Now, both of these tension forces exist within two dimensions, right? They both exist in the horizontal and they exist in the vertical. So let's go ahead and break these down into their component pieces. So we can call this T2y, we can call this T2x, we can call this angle 37 degrees. We can break this guy down, break this guy down. So T1y, T1x, and this is 53 degrees. Now, one key thing to also recognize here is this ball is stationary, right? It's just being suspended. So we know that it's in equilibrium, meaning that the acceleration is 0, and that the net force in both dimensions on this object is 0 newtons. So now that we've got our free body all done, the first thing you always want to do is start with the statement of Newton's second law. So I'm going to do it in both dimensions. So net force in the horizontal is 0. Net force in the vertical is also 0. All right, so two simple statements. So let's go ahead and expand. If we look at our free body, right, in the horizontal, we got T2x balancing out T1x, and we have T1y and T2y balancing out the gravitational force. So let's go ahead and reflect that in our second law statements. So T2x minus T1x is equal to 0 newtons. And T1y plus T2y minus mg is equal to 0 newtons. Now here's the problem. We've got 4 different unknowns running around, right? 1, 2, 3, 4. So what we need to do is we need to try to get rid of some of these unknowns. So if we look back at our free body here with the components in it, we need to get these in terms of T2 and these in terms of T1, right? So if you look at, let's just look at T2 and you guys can figure out T1. If you're looking at the cosine of 37, well, the cosine of 37 is adjacent over hypotenuse. So T2x can be written as T2 cosine 37. Likewise, sine of 37 is equal to T2y opposite over T2 hypotenuse. So T2y can be expressed as T2 times the sine of 37. So now we've taken these two unknown variables and put them in terms of a single unknown variable. So So let's go ahead and do that in our Newton's second law statements. So we get T2 cosine of 37 minus T1 cosine 53 is equal to 0. And here we get T1 sine 53 plus T2 sine 37 is equal to mg. Now, the issue a lot of entry-level physics students have is they see all these cosines and these sines floating around, and it gives them tired head, and their eyes glaze over, and they freak out. But here's the thing. Remember, cosine of an angle, sine of an angle, they're all just numbers. So if it's freaking you out, let's just turn them into decimals, right? People seem to be more comfortable with decimals. Now make sure your calculator is in degrees and not radians. So cosine of 37 comes out to 0.799, so 0.799 T2 minus 0.602 T1 is equal to 0. All right, on the other side, sine of 53 comes out to 0.799 T1 plus 0.602 T2 being equal to mg. Now the problem is we still got two unknowns running around. So what we need to do is work with a system of equations. So what we need to do is put one of these variables in terms of the other. So let's go here to the more simple equation. So we can rearrange this to get 0.799 T2 is equal to 0.602 T1. Simplify that even more. We get that T2 is equal to 0.753 T1. Right, so now we've got T2 in terms of T1. So what we can do is wherever we see T2 on this side, we plug in 0.753 T1. So let's go ahead and do that. So you get 0.799 T1 plus 0.602 times 0.753 T1 is equal to mg. So let's go ahead and consolidate all our T1s. So multiply and then add. And we get 1.25 T1 is equal to 4.9 newtons, right? The mg that we had found before. So T1 comes out to 3.91 newtons. All right, so we're almost done. Now what we got to do is take our T1, plug it in here so that we can solve for T2. So 0.753 times 3.91 will give us T2. So T2 equals 0.753 times 3.91. So T2 is equal to 2.95 newtons. Right, so by putting one variable in terms of the other, you're able to solve equations that have two unknowns. So keep this in mind when you get your next daily problem, because you'll probably need to use this information. All right, hope that helps. See you in the live engagements.